Hello, welcome. You're listening to the IT/OT Insider podcast. I'm your host, David. Subscribe to our blog or to our podcast on your favorite platform to learn more about our work, or go to IT/OT Academy to discover our training. Now, if you have been following our blog, you've probably seen that recently we have published a new industrial data platform capability map where we talk about the ins and the outs of industrial data. And what we basically do in this article is we break down industrial data into, from a very high level, ingest, enrich, store, expose, and then we convert that into core capabilities and supporting capabilities. Now, as it happens to be, our guest today knows quite some ins and outs about the ingestion part, about the connectivity, about the data part. So I'm super happy to welcome Kudzai Manditereza to talk about industrial connectivity. Welcome.
Thank you so much, David, for inviting me onto the show. Really excited to be on here. Looking forward to unpacking more about, all the connectivity stuff today. Thank you.
Absolutely, yes. So Kudzai is the brains and face behind the popular YouTube channel Industry 4.0 TV. That's also how I came across your work and how we started talking. And he's also the senior industry solutions advocate at HiveMQ. So before we dive into the connectivity and all the geeky stuff, why don't you just start with a short introduction from yourself, Kudzai, where you started, a bit about the steps in your career.
Oh yeah, absolutely. Yeah, so well trained as an electronic engineer. Early on in my career, I was into embedded systems design. So, basically, doing some microcontroller, programming, PIC microcontroller programming. That was for a gas detection company. So basically, designing these gas detection instruments that, miners take with them underground when they, go into the different sorts of mines. So that's kind of like where I really started out my career. And then from there, I then moved to industrial automation. So I worked for an industrial system integrator. So this is where I really, started to experience a lot of, manufacturing technologies. So I was specifically doing PLC programming. So my first experience with the PLC really was with, fortunately enough, because I was moving from the world of C programming. Yeah. So it wasn't easy for me to, jump into ladder logic and things like that. So fortunately enough, I was working with Groove Epic, or back then they were still called Snappack. So that's from Opto 22, which is a PAC, kind of like a hybrid between a PLC and a computer, which allows you to, write some scripting, technologies. So that was a good segue from me to move from embedded systems into industrial automation. And yeah, I mean, this is where also it became evident for me, again, all these inefficiencies as far as, connectivity is concerned, just, working through, a manufacturing facility and seeing all of these pen and paper, record keeping, and, just the way everything was just siloed, and kind of like, this is where I started to, look into this. And back then it wasn't really, I didn't kind of like think about it as IoT or IoT or, IoT connectivity. It was just me wanting to see how best I could get access to, data from these, PLCs. And then turned out this was actually a thing out there. There was a web that was going through. So this is kind of like what led me to move more into the IIoT space and kind of like started to investigate some more on that. And long story short, I started to, work with a lot of technologies, including OPC UA, MQTT, which is, what led me to where I am today as far as HiveMQ is concerned, working for HiveMQ as their industry solutions advocate. So yeah, I mean, this is kind of like a nutshell my background, and I've sort of like, doubled down more on the media and education side of things. So kind of like become more of a technology communicator, which is not something that I kind of like thought I would have as a career, but it turned out that this is, this was the path for me.
Yeah, it was also not really on my bucket list a couple of years ago, but so all of a sudden it happens, I assume.
Yes,
But anyways, it's
absolutely.
really really good to have your insights also in the industrial community, and so the topic of today, I was thinking like how should I introduce this, but I often like to use this term 101 course. If somebody in typically it's a concept from the States, I guess, I don't know, but typically when you go for a 101 course, it's the introductory course. So let's make this into this data connectivity 101 course. Um, we have been in different articles been talking about protocols, and the most important ones are, of course, OPC, OPC UA, and MQTT today in the industrial connectivity domain. Um, but we never really touched upon them. We never really explained what they do, what the differences are, where they come from. I must say, I still come from the OPC DA and HDA times. I actually remember that back in 2000, I think 11, 12, I did some first tests in converting some OPC DA connections into OPC UA, just to come to the conclusion that almost zero vendors supported it at that point in time. Um, and that's, from my perspective, actually a bit the end of my journey, because then I really moved to the platform side, the data, the AI side of things. So where should we start? Should we start with OPC?
Yeah, I guess let's start with the OPC, since obviously this is came first, as far as the standardized connectivity protocols are concerned. So maybe I think we could start with just to bring some context here with a brief background of exactly where this is all originating from, right? I mean, so I think we tend to think that obviously the issues of standardizing data collection or connectivity is something new, but this is something that in the industry has been struggling with for a very long time, right? And so this is also part of what led to the creation of the OPC foundation, or kind of like the first OPC, as you mentioned, or OPC DA or OPC Classic, is kind of like they would call it. And the problem was basically the same, right? You've got these many different devices and machines on the floor, and the only way to get this data from these devices was to have these, each vendor having its own custom drivers for a specific device. And then kind of like the natural thing obviously there was to say, can we not standardize this, right, and have a standardized way of getting data from the shop floor. And Microsoft, who are sort of like the custodians of OPC, turned out to have already done this with the printer drivers, right? So you could literally just use the printer drivers to literally talk to any printer. So the printer manufacturers, they kind of like built all of their drivers into that spec, and then they kind of like took that same, literally that same technology, that COM that existed in Windows, and kind of like used it for the to create this OPC UA server, whereby you're exposing a standardized interface, so that when you start to build your HMIs, your SCADAs, and stuff like your historians, you're connecting through that standardized interface. So that was a huge leap, right, as you would
I,
imagine, in productivity.
yeah, I actually didn't know it came from print. I didn't know it came from printers. That's actually a cool sidestep.
Yes, absolutely. Absolutely. Yeah. And kind of like, so that was the OPC Classic. And for, many years, this, I mean, when it was created, then obviously they didn't kind of like, I mean, that was in 95. Internet was just, getting started. So no one even thought that devices would want to communicate over the internet. No one thought that you'd have actually Linux on the shop floor. So all of these things were really,
Yeah.
foreign at the time. So that was everything. It worked perfectly, but then sooner it became a constraint, right? Having that operate only on sort of like a Windows environment. And it also didn't have like a a data model, like a complex data model, as you will. And so kind of like that was led to then revising that to start to think about OPC UA, which is a unified architecture that then is more cross-platform and has also this ability to, communicate over the internet. So this was kind of like, to align with more Industry 4.0, technologies or, the movement. So that was kind of like the journey for OPC UA. But I think for me, the interesting aspect of OPC UA, so unlike you, I started with OPC UA and then kind of like, made my way back to investigate more
Yeah,
the
yeah.
OPC classes, right? But what was really, interesting for me with OPC UA, when I came across OPC UA, it was just so astonishing to me how everyone was using it. Well, wrong is not the right word, but everyone was underutilizing OPC UA. Like
Yeah.
5% of people were really, maybe using it correctly, and it was more around the treating OPC UA as OPC DA but cross-platform and kind of like just using it for data
Yeah.
access, right?
Yeah.
And I kind of like, as I discovered that this has got a very powerful information modeling capability behind it, for me, that was really, astonishing. Even to this day, I think OPC, there's really no, technology that, can match the information modeling capabilities of OPC. This is kind of like what sets it apart.
Mhm.
And so this is what sort of like drove me to sort of like put together also a series of tutorials on my channel, because I
Mhm.
thought this is the information that needed to be out there. A lot of people needed to know all this information modeling capabilities of OPCA. So obviously, as you imagine, that opened up a whole can of worms, right?
Yeah, of course. Can you give can you give an example of such an like a basic information model? What would be something you typically find?
Yeah, so I mean, if you are reading data, for like from your traditional protocols like your Modbus and all these other protocols, the the data model is kind of like it's your tag, right? You've got that register and that value. So again, with Opus UA, you can pretty much use it in its bare bones like that, where you're using to access a specific data point. But when we are talking about a data model, we're talking about the ability to represent, an object. So because a shop floor is full of objects, you've got a pump, you've got a compressor, you've got this and that. So instead of having these, data points being represented as just discrete, sort of like, data points that you just collect. And then if it gets into a database or the IT side, you have to start to rebuild that and say, okay, this one is this temperature, this is the current. Rather, data modeling on the standard itself with OPC is to kind of like be able to describe objects using the language of OPC because it has got this, the strongly typed language that allows you to then say, this is a variable, this is a type, this is a pump, this is and so on and so forth. And then you're able to use some references to then link to say this pump actually belongs to this machine. This machine actually belongs to this line. This one belongs so you can actually build this complex representation of
So
information.
so that means that if I am a machine builder and I make a unit, I could actually ship my unit with a pre-built data model, which then the user who is installing it, the end user who is installing it at their facility, could then, without effort, ingest that data model in their historian, SCADA, DCS, whatever.
Oh, yeah, absolutely. And actually, the OPC sort of like standard takes it a bit further, but kind of like just to go back to what you said, where, as a company, you could say, sort of like, talk to your machine builders and say, this is the standard or this is the model that we want you to back into
Mm-hmm.
whatever machines you supply to us so that it becomes a plug and play scenario within that company where if it's a compressor, it follows this certain information model for OPCUA, then all of our applications are able to automatically pick that up and we don't need to custom build interfaces all the time. It's reusable. But the foundation also took it a step further and said, instead of you being able to do that, let's also, create what are called companion specifications, where you're using the same base information model to then define, standardized specifications for each industry vertical, where you're able to even reuse it among many different companies, not within just one company, right?
And that spec gets maintained by the OPC Foundation themselves, or
Yes, so there's a working groups, different kind of working groups. So with mechanical engineering, electronic engineering, so robotics. So there's many different working groups that sort of like take care of these different companion specifications.
it's interesting. I have a couple of questions, but maybe before we do we do a deep dive in those questions, maybe we should put MQTT next to that, because typically many people, they use OPC and MQTT in the same sentence. They go like, yeah, we do this or that. So where does MQTT then come from?
Yeah, absolutely. And I think, that, debate, I mean, that's an age-old debate, right? Where OPCA versus MQTT. And to some extent, I think it's more misinformed debate, right? Because these are kind of like, two different, tools for two different, problems, right? So maybe just kind of like give a quick background of MQTT. So MQTT also started in the oil pipeline for monitoring oil pipelines, right? So kind of like really for remote monitoring. And the challenge there was obviously you have got limited bandwidth on your all your devices, and that was that was like 99. So like that was kind of like a huge challenge as far as bandwidth is concerned. So they wanted to be able to build a protocol that allows them to be able, that is really light on the wire and very bandwidth efficient. And on top of that, they wanted to kind of like to move away from this idea of having to poll, because if you're using the client server approach of collecting data, where you've got like a client that polls the server, again you're consuming bandwidth. So they wanted something that is more changes that whole paradigm. So that's why they adopted the publish, subscribe mechanism of communication. So basically, the idea was to say, instead of having a client and a server communicating directly, let's put an intermediary or man in the middle that kind of like handles, communication between the client and the server. So which in this case is the publisher and subscriber. And you can kind of like achieve a bi-directional communication, because each client that connects to that central MQTT broker, that server, that mediator, can actually become a publisher and a subscriber, so they can exchange information without having to know anything about each other. So that was kind of like a huge benefit as far as savings, more specifically on the bandwidth side of things.
That's actually a bit, if we compare, we talked about printers going into, I would say, OPC. In this case, we can also compare that to early news groups in IT systems, where again in the 80s, I assume, also on the IT side, bandwidth super limited. So this idea of publishing news to a news group and then subscribing to that is actually more or less the same, I guess.
Oh yeah, absolutely. I mean, and it's really interesting because MQTT was, like, as I said, founded in 1999 for industrial use cases, but for like 10 years, for like a decade, I would imagine, up until early 2000 and 2010s. I think this is where MQTT started to regain popularity more in the industrial space. But during that gap, it was mostly used in kind of like the IT side of things, with companies like Facebook, of course, that are implementing it in its messenger platform. And then it kind of like regained its popularity into the industrial space in kind of like the 2010s. And because more in the IT, this is more where this idea of a publish, subscribe, mechanism was sort of like making sense, I would imagine. I mean, even to this day, they still, engineers or kind of like people in the industrial space who, for them, it still doesn't make sense, this idea of publish, subscribe. So traditionally was still used to things being directly connected to each other, directly coupled to each other, right?
And the objects, the way you depict objects in OPC, from an MQTT perspective, that is not entirely the same. There we talk about topic structures, if I'm correct.
Yeah, so absolutely. So, MQTT is a transportation protocol, right?
Mhm.
So it doesn't dictate what payload structure you should follow, right? So you kind
Yeah.
of like transpose your data, and opposed to OPC UA, which kind of like has got an opinion on how you should model the information. But it's something that I found interesting, that still kind of like a lot of people still maybe may not be familiar with, is a lot more capabilities within the MQTT protocol that makes it more than just an M to M, because for a long time MQTT was used as a sort of like this M to M, sort of like you send this
Yeah.
data to that. So in a way, it was you're using it as a for direct connection from one device to the next. But the MQTT topic, which is a way of addressing information within an MQTT broker, way of using like a hierarchical structure to be able to say this information belongs to this specific root folder, and then you kind of like create those data access. That is a very simple concept, but kind of like it's a huge implications to how you structure information, and it is the reason why it has even led to concept like the unified namespace being
Yeah.
easily or associated with MQTT, because it kind of like just maps nicely to that hierarchical topic structure, because now you're moving from this idea of just point to point or this kind of like M to M communication, but just kind of like using that topic structure to share the information as your folder structure, just like how you'd use a Google Drive, for example. You kind of like just putting information in relevant folders, so that whenever someone wants to look for information, they kind of like just simply go through those folders and discover all of this information. So that's kind of like a huge thing about MQT that I think maybe a lot of people still take for granted to this day.
From your personal perspective, like are there reasons to use one or the other, OPC or MQTT, or because I think in most cases bandwidth won't be the big issue anymore. I can imagine that publish subscribe is very interesting in certain cases. For example, especially for IoT devices where you want communication not towards the IoT device, but from the IoT device towards a broker. But from your experience, would there be reasons why one would choose for one or the other, or is it more about what you already have, what your legacy is, what your I don't know?
Yeah, and I think this is kind of like a good point to address. I think maybe I didn't quite address your question before, to really, again, if anyone can kind of like take something away from this discussion, is kind of like this clear separation of kind of like concerns as far as OPC UA and MQT is concerned. So as I mentioned, OPC UA is all about providing a standardized interface for all your shop floor objects. So it exposes this server, right, that kind of like abstracts all of the implementation of the different PLCs, different pumps and things like that, and then kind of like it exposes that server that then allows things like SCADA systems to connect into that, and then maybe display the data and also kind of like provide that back and forth, and then that works fine in sort of like maybe a cell or a line where you kind of like this closed loop control process that is happening, right? But as you then want to sort of like integrate your data across an entire enterprise, now if you kind of like think about a situation where you've got like thousands and tens of thousands of machines, that you want to have a unique identity within your entire ecosystem, and you want to sort of like integrate those and connect them into sort of like an enterprise or IT system. This is kind of like where that tight coupling really kind of like just falls apart, right? So my sort of like approach to it is to say you use OPC UA from level 2 up to from level 0 up to level 2, and maybe at level 3 this is where typically you want to put your broker, or rather in the
Yeah.
demilitarized zone. This is where you've got an MQTT that kind of like takes over from there and then does the integration with your IT system. So you'd never control a pump using MQTT, or you never try to open some critical assets or control some critical assets using MQTT, because it just doesn't have that
it doesn't have that type of connectivity you need to do real-time control. That's
exactly.
Yeah. But that's a very interesting one, because I think that's also, if I may say so, probably one of the common source of misinformation, or at least people not really understanding the differences well enough, is that in this closed loop control situations, you don't want to build something where you don't want to build something where you have to publish something into the broker, and then the device itself needs to keep on polling for the request.
Yes, absolutely.
The result. I'm sorry, the result, of course.
Yeah. So yeah, I mean, exactly. So this is where, for example, it would make sense if you wanna, adjust some settings. So maybe you've got a setting that is coming from your MES system or whatever system. Maybe it's going to the DCS system. So maybe that's not really a critical set point. No Sorac system is polling and waiting for it. That you could have that information coming down from your MQTT, broker down into the sort of like control environment, as it were, but not interfacing directly to opening your critical equipment.
No, because, for example, if you take that example, the DCS system, it knows it can get at certain points in time, it can get a new set point, or a request to produce a recipe or whatever. So in that case, you're implementing the logic to wait for that message in the DCS or the SCADA system. But then, if you're then cascading that down, then indeed you come into the real-time part.
Yes, absolutely.
That's a very important one. I think that's misunderstood by many people.
Oh yeah, absolutely. And also, it's a huge misunderstanding. And also, one of the things that I kind of like try to paint, I do a kind of like a whole lot of evangelism and thought leadership around unified namespace. And one of the things that I kind of like try to point is that MQTT is, or the unified namespace by, whatever. I mean, I think maybe let's stick to MQTT, because unified namespace, I feel it is, it's been contested a lot, right? There's different, versions of what unified namespace is, right? So, but rather this ability to be able to exchange events, right? This ability to be exchange events in an event, something that has been done in IT for a long time, where if, for example, you mentioned the idea of a recipe set point, and then maybe the DCS system has finished, making whatever it is making, and then it kind of like, raises that as an event. It's not really waiting to know if someone, receives it, acknowledges, but it can share that information as an event to the MQTT broker. And then that's very, important information. So if a machine breaks down, that is an event. That information is shared into the MQTT broker. So at the end of the day, you end up with having that current state of your business. You know the state of every machine. You know the state of every application, but you don't necessarily need to control how it performs its operation. So your unified namespace is kind of like that snapshot that gives you that snapshot of your current state of your information. And MQTT is very good at doing that, holding that real-time event of your business.
And actually, just the fact that you mention events makes me also, if I look to most implementations I see where a SCADA or a DCS is getting information from a third party source. We gave recipe as an example, but for example, quality data. That's also something I often see, where for example, you have a lab system, a lab technician makes does something, measures something, and then you want to feed back that quality information into the DCS to then use that for an advanced control algorithm or an optimizer or just change a set point or whatever. Most of those interfaces today are just file based. It's like a file on an FTP server, which you keep on pulling, or it's an XML. But just I think having a better understanding of event-driven architectures, which IT is really good at. If the IT world wouldn't have an event-driven architecture, the entire internet would collapse, basically. But in OT, we seem to miss that boat, or at least many of us seem to have missed that boat. So I think that's, yeah, I don't know if you have something else to say, but it's just like a personal rant here at this
Yes,
point.
absolutely. Absolutely. And it's like I said, it's something that is difficult to wrap your head around, maybe if you're kind of like thinking about it for the first time, because you're kind of thinking about this mentality where applications need to actively reach down to the shop floor and ask for information and get information rather this idea of event-driven architecture to say you don't need to think that way, rather you need to kind of like just push those events to that event broker that kind of like holds all of that information, and then that can be reused for many different purposes. And this is where also one big misconception about the unified namespace, where a lot of people still don't understand this idea that you reuse data, right? Because we have not we have not thought about data as an asset, obviously in the industrial space, but the ability to reuse data is a huge factor, right? So you don't need to always do some heavy lifting whenever you want to address a data use case. You always need to set up the connectivity infrastructure. You can actually do that definition of your events, definition of your enterprise, and then start to reuse that data for many different purposes, and then kind of gives you that agility or that speed to be able to address all the use cases.
It's this platform product type of thinking, again something super common in the IT world, where you okay, maybe not the best example, but let's take OpenAI and ChatGPT as an example. They have something, they have a backbone, and they just say to everybody who wants to build some application on top of it, just do here is the definition, here are the APIs, here is the cost, of course, as well, and just build on top of that. And I think if you have that availability, so suppose that I need to build my own LLM first or install LLM software or whatever, then probably I won't start. But if I can just link to the ChatGPT API, then I can start building whatever I want very easily. And I think the same is true. And I like the fact that you say that, and I just want to emphasize that as well, is that this scaling approach is so important in the industry as well. And I think that's also one of the major reasons why real digital transformation is going slow. If you came across examples where, good or bad, or something to share in that aspect as well?
Yeah, I mean, well, I think this is a common issue, kind of like the sort of like the. So we have spoken to some companies here who had initially, had a projection. So they kind of like they had a list of use cases that they want to address, and then their projection. I might be wrong about the numbers, but that kind of like gives you a clear, ballpark where they had, projected about 10 years it would take them to address those use cases. But as soon as they started to think differently about data reuse, that dramatically went down to like 3 years, like when they address those use cases. So I could be wrong about the numbers, but that gives you kind of like that ballpark of exactly how that shift sort of like allows that scale and speed for you to be able to implement.
Scaling, thinking in terms of scale is so important. And I think this is also a perfect ending of this episode. Before we close, we did a podcast a while ago with the authors of the book Unbundling the Enterprise. And that podcast was all about scale and a concept they call happy accidents. What they mean with a happy accident is if you have a platform, then accidentally finding something which makes sense suddenly becomes really easy. So for those listeners who haven't listened to Unbundling the Enterprise, make sure to do so. That's a wrap for this episode of the IT/OT Insider podcast. Kudzai, thank you so much for sharing your insights.
Absolutely. Thank you so much for the invitation. Really enjoyed the conversation.
And of course, also to our listeners, thank you for tuning in. If you enjoyed the conversation, don't forget to subscribe. You can find all links to all platforms on at itotinsider.com. And see you next time for more insights in bridging IT and OT. And until then, take care. Bye-bye.